on web view and on sharing. Those are really the best resources. Those are also the places from which essentially, I use in my slides portion of code that are taken from the Android documentation, and they're taken exactly from there, or mildly adapted from there. I don't know if they are taken straight from there or if I adapted them in some project and then I recycle, but it's essentially the same. And so look at it. That's a very good source of information. So that's very useful. Thank you. So sorry, I'm a bit confused with the too many windows open. So I want to go back to services to show you this sort of crucial slide. Which is, we know that when we create a service, we do the following. We call start service with an intent. Okay, so this is for started services that can run in the background. Okay, otherwise we can just bind to it. If we create a service by binding to it, then the service is alive only during the time there is somebody bound to it. Okay, that's a way to do software libraries, and that's a way to do, things that don't really have an independent background life, but maybe, they acquire a sensory data in the background, but as soon as nobody's interested in the data, they shut down, okay? So instead, if you want to create something that has an independent lifespan, you have to create it in a started way. And so you start service with an intent. The service will execute its own create method. And I told you that if you wanted a service to have any independent life, it must obviously have its own thread, right? Because otherwise it cannot really execute separately. And I also told you that the tricky thing about threads is that there are these two independent notions. One is the syntactic scope of your code, and the other one is the dynamic context, essentially which thread is running it, right? And you have to keep the two distinguished, okay? So there are threads and there are classes, but the boundaries of threads are not the same as the boundaries of classes, obviously, okay? So if one class you call another, it's the same thread running in both. We will see later what this implies, okay? But so a service needs to create its own thread so that, I think I forgot to screen share, sorry, let me just set it up so you have this as well. Okay, so the service creates its own thread, starts as a thread, and then the service task, which is the thing that the thread runs, starts running. So I think last time we reached this point, okay? And now the point is how to communicate back and forth, because now you have two threads, and actually if you declare the process, if you declare the task to be running in its own process, what you really need will have is two separate processes. So, but how do you communicate back and forth between the two, okay? What can you do in order for this to happen? Well, first there needs to be, first the activity must know about the service. Because the activity, all it knows at the beginning is that it has sent a start intent, okay? But it does not know then how to communicate with the service in any way. It does not have like a handle or a pointer or a thing or an object that it can actually call. So this is mediated for generality by this notion of a binder. So you say bind the service intent, and what you get is a binder. And I told you that we are doing in this class, as a simplification, a very simple type of binder. The binder is a class that has a single method that is called getService. And when you call it, you actually get a reference to the service itself, okay? This is a sort of, shortcut, but it's sufficient in many cases. It's sufficient in many cases because, the binder could be used to hide some internal methods of the class. And also it could be used to, rename methods in other ways or implement in general a layer of translation between the two, etc. But if you are building services that work with your own app, usually, it's fine. I mean, generally you already create two classes and you call from an object of a class methods from the other class, right? Yeah, so this layer of interface is unnecessary, really, if you are building things in the same app. Okay, so here is where we arrived the last time. And once you have the service, if you call my service foo, this will execute the method foo in the service. Okay, in the same thread as the activity. And now the difficult thing is this: if you are in this method foo of the service, you can call task foo as a method of the service task that the thread is running. You can do that. But if you do that, this task foo is gonna run in the thread of the activity, not in the thread of the service task. So you have to be careful, and you have to use locks. If from task foo you modify any variable that is local to the service task. I mean, you have to be careful about mutual exclusion to critical sections of code, essentially. Okay. Have you done these notions of in operating systems? Can you tell me? Raise your hand if you have not seen these. Have not seen what some locks are to protect data structures from concurrent access. So if not, okay, so a few people have not. So I think I'll have to make a parenthesis and show you how it is done, but it's actually fairly easy. Okay. Now there is also the opposite point. How does the service communicate back with the activity? Because the binder gives to the activity a description of the service, but not vice versa. Okay. So what is a good way to implement the vice versa? The good way to implement the vice versa, okay, sorry, before I get there. How do you stop the service? So there is one thing that is peculiar to Android, maybe it's general in Java, I'm not quite sure, but it's certainly true in Android. You actually are not supposed to ever kill threads, because the threads do have a method that is called, I think, stop or destroy or something like that. But if you call it the proper garbage collection and resource deallocation that is supposed to happen at the end of the thread executing does not happen. So you actually don't stop threads in a brute force way in Android. What you do is this. When you should always have in threads a Boolean flag that tells you whether you should continue running, and you should check it periodically. Okay. If you notice, this is what I do also in the async task where I do the downloads from HTTP. If you read that code carefully, there is a flag that says, while the number of attempts is smaller than the max number of attempts, and I haven't been stopped. So, I periodically check that the thread has not been stopped. And here I need to do the same, okay? So I need to introduce essentially a Boolean flag that here I call simply alive in the example. It's declared as a class variable of this service task, okay? And when I run, I have to check while alive. So periodically, if I have a loop, I mean, typically you have some kind of loop. If the process is to last forever, you generally have some kind of loop or another. For example, you have something that says, I don't know, sleep for while alive, sleep for 10 seconds, and then check if there are any new messages. This is perhaps a very simple implementation. You might have more sophisticated ones. For example, you might decide that you want to wake up every 10 minutes using an alarm clock that every time you reschedule in the future, right? And so just before rescheduling the alarm clock in the future, you should check whether you are still alive. And if you're not alive, you simply exit, right? So there is a little bit of delay between when you wish the thread to stop and when the thread actually stops. This little bit of delay can also be several seconds sometimes, depending on how often you check in the loop. But this is the way things are generally, okay? So if you want to stop the service, what you do is this. What you do is that you send a stop service intent. This is how you ask for the service to please be stopped. This will trigger the onDestroy method of the service, okay? And this will stop this. This will, deallocate the memory and the stuff in the service. But in the service task, that thread is still running because nobody told it yet that it has to stop. So what you have to do is that from the service in the onDestroy method, you say stop work, and this stop work essentially sets alive equal to false. Now in Java, you would have a little bit of trouble with this in general, not in this particular case, but in general, you see now we have a variable that is called alive that we modify from here and we test from there. And you may ask, is this okay to do? And so this is not okay if alive was a string, okay? The reason is that there can be two processes at once, one that reads the string and one that writes it, okay? And so if you reassign these things, at least actually for strings I'm not quite sure, but if this was a complicated data structure, you should not modify it from one place while you read it from the other. Because otherwise you might be reading some things that are, you know, that are in sort of in between state. Then you should really use locks, and I will explain in a moment how to do that. However, in Java, you have guarantees that some of the basic data types are modified in an atomic way. Booleans are certainly one of those. Integers are one of those. I believe floating point numbers are one of those as well. Okay. Strings have a bit of fuzzy impression because a string essentially is immutable in Java, and so all you do is change a pointer. So I believe strings are fine, but I would need to check the documentation. I don't know if we have a Dustin that is able to Google it so quickly. Okay. But essentially, there are some data types in Java that you can modify. So you still have the problem that, you know, they can be modified by two threads concurrently. But in this case, this is no problem anyway, right? Because the other thread is only going to check it, while there I'm only going to feed it to false. So this is actually okay to do without any other precautions. Okay, you will never read like a funny value between true and false from the main thread. Okay, from of the service. So this is a very common way for stopping the service. Okay. Now there is the problem that I wanted to describe to you earlier. That is, how can the service send things back to the activity? No, because the service doesn't really have I mean, the activity has this binder that tells it what the service is, but the service itself instead does not have a pointer to the activity that created it. It's a funny thing, if you will, right? But when you get the intent to be started, the intent doesn't contain the fingerprint or the pointer or the whatever to the activity that asks you to start. It's a bit of a I don't quite know why they decided to do it that way. No, some things would have been simpler if you got somehow a reference already in that intent, but it's not so. So what you do is this. I mean, you can do in many ways, but a very typical way to do it is this. The activity that started or that wants to talk to the service registers with the service for updates. It's a little bit like, I don't know in the real world what the comparison would be, but it's a bit like when you go and say, you know, hey, my address is this, you know, if you have any mail, send it to this address. So this is what the activity is doing, okay? So the activity is calling something that is called myService.addResult callback, in which it sends main activity this. So it sends a reference to the main activity, okay? That is what the activity is doing. Now, this addResult callback is a method of the service, not a method of this thread, okay? So this addResult callback will say, okay, sorry, I need glasses. So it says my task add result callback of result callback. So this simply, you know, passes it over to this add result callback in the task. And so here there is some code that needs to be implemented carefully. I will give you the precise implementation. You say add result callback. You have essentially a list of things you have to call back when you have results. This code is written in a very general way. Okay, often this list of callbacks is a singleton. You have, you know, only the activity that created you is interested in having result callbacks. But the code is written in a general way because it becomes a sort of boilerplate code that you copy from one piece of work to the other. It's written in a general way so that this works whenever you have a single activity that wants to be alerted of results, or whether you might have many activities that want to be alerted of results, okay? Basically, all these activities are sending a reference to themselves, and in the service task, in the thing on the right, you add them all to a kind of list of things that you have to notify whenever you have results, okay? So you build this list. Now, here we will have to be a little bit careful about concurrency, because a list is not an atomic data type, and so we will have to be careful about how to modify it, and we'll show you directly the code of the details, okay? Do you know about the strings? No, yes. Are immutable, so they're safe, yes, exactly. They would not be safe otherwise, but this is immutable. Right, yeah, exactly. So that, because it's just to switch a pointer, which is atomic.
Yeah,
every
write to a byte is atomic, 32-bit write is atomic.
Yeah, so well, that would mean that doubles are not atomic.
Okay,
I always get calls when I teach. So great. Where I am. Okay, here. So once you register the callbacks, how do you actually send the information back? Okay, what you do is this. Whenever you want to give back a result, you call, say, notify result R, where R is the result that you actually want to send back to everybody who is interested, okay? Now the activity says registered, and you have this R to send back, and you say, notify result R. Now, the following happens. In the service thread, you have this method that says notify result R, that says, this code is a bit imprecise. I will show you the real code. But essentially, it will call the onResult method of the activities, of all the activities that are registered. I will show you this in the actual code. Here, this slide is, I'll fix it, omits some small detail, I think, in order to fit better. But essentially, you call onResult R of each activity that you want to pass R back. And now we have this conundrum, okay? Now we are calling a method that is called onResult R of the activity. The problem is that in the method onResult R, I think what disappeared is that this is the code of onResult R. There is some typo here that I don't quite understand, so it must have gotten corrupted a little bit, but I have the full code, okay? So the problem is this, when you call back onResult R, you're still running in the service thread, not in the thread of the activity. So you cannot simply, happily modify the UI or activity variables or things like that, okay? So you have two choices, essentially. One is that you build a runnable object and you ask it to be run in the UI thread. Okay, this is choice number one. Another choice is that you build a message and you send it to the activity itself. So you are in the activity, but you are in the wrong thread of the activity. So now you build a message, okay, and you ask for the message to be delivered to the activity, and then you implement the handling of that message. Okay, so there is a notion of messages. I will do later a lecture on all the various interprocess communication primitives that actually will be helpful for graphics as well. But the idea is this, if I can draw on the bottom of the bar 1 second. There is a notion of a looper that manages all the messages that are incoming, that all the stuff that needs to be run that is incoming to the activity. Okay, when you're in the activity thread, you can create a looper, and I will show you how the code for doing this. It's something like looper init looper command like that. Okay, but after you init the looper, you have a sort of queue of things that should be run in that thread. And the queue can get two types of objects. It can take essentially some randomables. A randomable object is something that has a method run. So if there is a randomable object, the activity will take it and run it. The thread will take it and run it. And the other thing that can be inside these are messages. Okay, and messages are delivered to a message handler. You know, so essentially, what is incoming to an activity can be things of these two different types. Okay, now the fact is that messages are a bit more. So I mean, there are two different notions, but messages are more flexible in the sense that messages can actually cross process boundaries. So if you have things that run in different processes, then you need to pass information using messages. Okay, not randables, because randables, you know, they carry some of the reference to the scope to which they were created, and so they can be used only within the same process. Okay, so this is how it works, and I want to show you the code that does this in a bit greater detail. So essentially, the communication back from the service to the main activity works in this way. The activity registers itself with the service. When the service has results, the service calls back the activities and calls back this method that says onResultAre. At this point, the result R is in the activity, but not in the right thread. Okay, so we must do one of two things. Either we package the result R in a runnable and we say run on UI thread if the service is running in the same process, or as a more general solution, what we do is that we create a message that contains R and we send that message to the activity itself. It's a bit crazy, but this is the way it works essentially. And this is because essentially the boundaries of classes and threads do not coincide. Right? So we have here two classes, the service task and the activity. We are going to call from one back to the other, but we have to cross not only the class boundary by doing the call, but also the thread boundary, because you know otherwise we are executing stuff in the service thread, where whereas you know the result should be in the end processed in some thread related to the activity. So this is why it's complicated. We are essentially crossing two boundaries at once, not just one. Is this somewhat clear? I mean, it will be more concrete when we look at the code, but is the general idea at least clear, or do you have questions on the general idea? Everybody's so confused, I guess, that until we see the details, is have to say. So let me go to the precise implementation of this. Okay, so this is it. So let me, oh, I forgot my water bottle. Let me do a quick resume of what we did. Here, this is the main activity. In the main activity, what we do is this. We create an intent to start the service, and then we bind it to that service. The start service intent, I don't want to repeat, well, maybe let me repeat it, okay? Let me go in order so that we see the setup once more. I think it might be useful, okay? So when start service is sent in my service, we execute onCreate. In onCreate, we say, haha, we are now new to life, so I want to create my task, so the thing that will actually execute. I create a thread to execute the task, and I start the thread. And I told you that it's a good idea to do this in onCreate, because this will ensure that you get only one thread. If you do this on start, then you might create many threads, one for each time you are started. Somebody tries to start you, which is not ideal, okay? So this is what happens when you do execute onCreate. Now, in main activity, what you do after starting the service is that you want to bind to it, so that you have a reference to be able to do something with it. So you say bind service, which is simply a call to my own function, you know, that I wrote here essentially. And in bind service, you do the following. You create an intent and you send it to the service asking, please, you know, let me bind to you. And you pass, I'm sorry for these pop-up windows, and you pass a service connection. So it's the usual thing. When you need a reply, you say, hey, I want to bind to you. And, you know, once you accept or decline, please call this service connection and let me know, right? It's this asynchronous way of communication. And the service connection once you know, it has two methods. On service disconnect, in which the service essentially told the activity bye bye. This simply says that service bound is false. But if the service is connected, what you do is say you get the binder, and then you get the service by calling binder.getService. Okay, so this is what we had last time. At this point, as of the end of last time, the activity has a reference to the service. Okay, and my task is running in its own thread. Okay, and so everybody exists, but there is no communication back from the service to the activity. So how do you do the communication from the service back to the activity? Okay, so let's look at it a moment. Where do I do it? Here. Okay, so in this line here, once I get, once the activity gets a handle to the service, the activity wants to start to be able to receive information from the service itself. So the activity calls my service add result callback main activity this. So essentially the activity is passing itself to the service, asking it to be notified when there are any results. Okay. In the context of a homework we may write, assume that your service, what it's doing in the background, it may be checking whether there are new messages for you every 5 minutes or so. Okay. So the activity wants to be notified if there is any new message. Okay, because it may want to, pop out some information or change the state or do things like that. Okay, so this is one of the things you may want to do, for instance. So in my service, when you run add result callback, you do the following. You don't do very much. You simply call add result callback of my task. There is also a method to say remove a result callback. Okay. But essentially, this is just a pass-through, right? The activity calls the service, and the service calls the thread that is running inside. And the thread that is running inside is this one, okay? And in add result callback, it simply says result callback add result callback. Result. This, I mean, it all looks very, very silly. Okay, we're just passing it and passing it once more and adding it. The only interesting thing is the declaration of results callback, because results callback is one of these things that is a little bit serious. It's one of these things that is a complicated data type. It's essentially a list or a set, but one of these list set objects, and the problem is when you add the result callback, because you simply call each other, etc., these will be running in the same thread that the activity is running on. So this runs in the UI thread, right? But then when the service generates a result, it needs to access the list of listeners from another thread. So here we have a complicated data structure, a list that can be accessed from 2 different threads. Okay, so the problem is that, a list is a complicated inside. I don't know how they implement it, but at the minimum, I think you have all taken data structures at UCSC, right? So at the minimum, if you have a list, there is, an element that contains the list linked to the next. I mean, let me try to make it a bit more concrete, right? How do you add an element to a list? I don't know, maybe this list, for all I know, maybe a bidirectionally linked list. So you have a reference to the first element, and every element is done in this way. It has a value, and then it has 2 pointers, The one that points to the next element, okay? And this may point to nothing because there's no next element, and that one that points to the previous element, and this points to nothing. So if you add a new element to this list, what do you need to do? You have to create a new element, then you have to modify this pointer so that it points to this. Then you have to modify this pointer so that it points to that. And when you do all these modifications, the list is left in an inconsistent state. Okay? So for example, at some point you will have added this pointer, but not yet that. And you can run this map, of course. So you can try to say, but I'm very smart. I first do this pointer. So as long as I know, as I progress the list, I don't yet know that this exists. So if I try to read the list while I'm still modifying it, nothing very bad happens. And only at the end, when I magically, also, to some extent, you can make sure that by individually crafting the update process that you can modify and read it concurrently. But this only goes to some length, because another problem that you may want to do is having data structures where multiple people may want to modify them. Okay. So in general, the solution is this. So in general, the solution is this: that you have some data types that are called synchronized. So these results callback is a collections synchronized set. Okay. In which you create these essentially it's a synchronized version of a hash set. What does it mean by synchronized? This means the most general way of synchronizing these things is this. There is a control, there is a concurrency control on the way in which you can call the methods of these objects. That essentially ensures that at any time there can be either at most one writer or many readers. But there can never be two writers or a reader and a writer at the same time. Okay? For essentially multiple readers is fine because they, if they all read but they don't modify, they are all reading some information that, and they will all get the same status. But if they modify, then this is not fine. So at the entrance of these data structures, actually, I have to say, I don't know if they distinguish read methods from write methods in these, or if they use a more simplified approach in which they just check that there is only one thread at all inside. I don't know for these sets, because the modifications are so short that it doesn't matter. The more sophisticated way to do it is to distinguish methods that read only and methods that also write, and to essentially, in the implementation of the synchronized sets, which is something I don't want to get into in this class, put the appropriate locks that ensure that there is at most one writer or multiple readers. Okay. The more brute force way to do it would be to ensure that there's only one thread accessing calling any methods at the same time. Okay. Since you access the structures only by calling methods of them, then you are fine if there is only one thread executing any method. And this will ensure that you're not at the same time trying to modify it in two different ways or read it in two different ways. Is there a distinction of multiple readers? So one user all the time. Okay, so it's done in a not very sophisticated way, but it's probably fine. I mean, the truth is that these data structures are very. Most of the operations you do are very short-lived. I mean, take very short time. Now, they're basically, you have to add an element, you modify just a few pointers. So it's not, it may not be worth doing doing the distinction between readers and writers, except if you had very, some operations that take a very long time to read, which in this case, anyway, they didn't care. So, but these results callback is a safe data structure. You can call it from multiple threads, and it will internally stay consistent. This is one of the beauties of Java, that it has these consistent data structures. So going to the code again, add result callback takes this safe data structure and adds to it one element, which is the result callback, which is simply the reference to the activity. Okay. Now, when here we want to pass back a result, you see I have this running is equal to true, which is my flag. Sorry, it's really annoying, these pop-ups. But running is equal to true is my Boolean flag that indicates whether the thread should continue running or not, as I told you, for stopping it. So while the thread is running, I do something very silly here, just as an example. I sleep for 1 second, then I generate a random number, and then I pass it back to the activity. It's, I just want a super simple example. I generate a random number and I want to pass it back. So once I have this random number and I want to pass it back, what do? I say notify result callback of R. This, in notify result callback, what I want to do is this. I want here. I want essentially to go over all the list of the people that called me. I mean, no, sorry. I want to go over all the activities that registered with me, and I want one by one to give them back this result. So I do the following, okay? So in this case, I have these three results that is a list of buffers, okay? And I say, if I don't have any free result, I create a free result. Otherwise, I get one of these free results, okay? And then, so let me show you where these free results are defined, by the way. Okay, so free results is again a concurrent queue of results. So it's one of these objects that can be modified by multiple heads. So what I want to do is essentially this. I want to get, it's like when you do the security check in airports, no? You get one of these bins. No? I want to get one of these empty plastic bins in which to put my result. And then I want to ship these to the activity that might process it at its own place. So I have these linked list, you know, this pile of these empty bins, and I want to say, you know, at the beginning it's empty, of course, and so what I want to say here is something like this. So if I don't have any empty bins, then I say create a results buffer. Let's look at what it does a moment. I clear the old bins, and then I put here a single new result. Okay. So essentially, I initialize these with actually 10 of these empty bins. Okay. So I created 10 empty plastic bins to return my results in. Okay. Then when I have to return a result, I do the following. I take one of these empty bins. If the result is not null, because you know, if the result can be null here. If the result is null, it means that I ran out of empty bins. And in this case, I decide that I don't do anything. Okay, so I mean, there is a problem that you have to deal with at some point. That generally goes as follows. I have the service. I have this pile of empty plastic bins. I have 10 of them because I created 10 of them. Okay. But I may have a lot of results to pass back to the activity. When I pass these results to the activity, that is Dustin for this visual example, okay, I take this bin, I give it to him. He will essentially take the content of the bin and will give me back the bin. And then I will, you know, I'll have one more empty bin that I can put back, you know, and use it for other messages. Now, the problem is that my speed and his speed may be unrelated. Okay, so for example, at some point he may get really busy doing other stuff and can stop emptying his bins, no? Or else, so I have no control that he will consume my results quickly enough. So at some point, I must decide what to do. You know, here, what do I do if I get a null result? This means I'm out of bins. When am I out of bins? I'm out of bins when the people have not returned me the bins. The beans, not the beans. They tell me that my English pronunciation is terrible. You probably agree. So you see, this is what is done when the activity is done taking the information out of the bin. It calls release result, okay, and this will do free results offer of the result. So it essentially puts the bin back in the set of usable bins, okay. Bins. Okay, fine. So, but at some point, you may run out of bins. And so there are two solutions. One solution would be to say, hey, whenever I run out of bins, I create some more. This is not a good solution, unfortunately, you know, because, you know, maybe Dustin has gone to sleep for half an hour. And they continue to generate a result every 10 seconds. And they cannot generate, you know, 30 minutes times 180 bins just because he went to sleep for half an hour. I mean, at some point, if two things are in two different processes, and the other process is not responsive to you, there is a place in which you need to decide that you are going to drop the information. Okay? So it doesn't make a lot of sense. Even if I bins here, I need to give you an example, but it's probably exaggerated. I mean, there is only one activity that listens to the service. Either that, having two bins is reasonable. Because so while he's busy, looking inside the bin I just gave him, I can go ahead and fill the new bin for him, and we can pass them each other back and forth this way. 2 is reasonable. 3, fine. More than 3, I would argue, is a bit funny. Unless you really need to preserve the history of what went on in case he has bursts of activity. But at some point, you always need to decide that you give up. You have to do things always in the best effort way. It is absolutely pointless. The only, if you create a new bins per need, the only thing you do is you posticipate death, right? Because at some point, the activity will be shut down. It will send you the message that you need to die, and you will need to die at some point, and all those bins there will be garbage collected, right? It's not because they put stuff in the bin that it got delivered. So there is no point in generally letting these things accumulate too much. So here is our loss point. Maybe I should add a comment. If we got a null result, we have no more space in the buffer. I don't want to talk about bins because I didn't write it in the systems here. And we simply drop the integer rather than sending it back. Okay. But so instead, if we did manage to get hold of a bin to send to the activity, what we do is this. We set the int value of the bin to I, okay, and then for everybody who is interested in our results callbacks, we send them the result. Okay, so here I'm doing something that is a little bit absurd, and maybe I should fix the code, but I still do something that is absurd. Maybe I should fix it at some point. That is. The silliness that I'm doing is this. I get a free bin, and then I give this bin to everybody who listens. This is wrong. This works only because here I have at most one listener, right? Because if I give the same bin to 2 different listeners, then, how do I know when to deallocate it? I consider it free when the first of the 2 listeners, the 2 of them, calls my method to give me back the bin. And so, if I had more than one listener, it would be dangerous. I would need to modify this code, and I would need to modify it in a way such that I give each listener a different bin. I would essentially have to put this loop outside of this logic. I should probably do it, in fact, but I haven't done it. Okay, so I just want to make you notice that my code is actually broken if I had more than one activity that can bind to this. Okay, important notice. So, but essentially, I get the bin. I set the int value of the bin to I, and then I say result callback on result ready result. So I call the on result ready method of the people who added themselves to the be called back when I have results. So essentially, this on result ready is a method of the activity, because you remember that when the activity registers with the service, it registers main activity.this. I think we can go back and look at it. But you see, in the main activity, you say my service add result callback main activity this. So now, when from here I call on result ready result, passing back this bin, okay, this bin will be called in the on result ready, which is here. Okay, so that's what gets called. Before we go back, I just want to show you a moment what is the code of these defining these free results and a result, a service result. Okay, let's see whether I define them. Actually, service result is defined here, I guess. Okay, service result is a class that simply has a single object that is, is a class with an object that has a single variable, right, int value. I use it simply as a packaging. Okay, and instead, free results is a concurrent linked queue or that can contain elements of type service result. So it's again one of these concurrency safe types to which you can build a list of 10 of these elements, and then you can poll for one that is not used, and then you can put back some. You would have to look at the methods of concurrent linked queue to know what I'm using. Okay, but so an unbounded thread safe queue based on link nodes and yada yada, and then you can read all about the various methods. Okay, there is described here, etc. So okay. So let's make a moment for questions. So this is the first part of it. That is the activity that registers itself with the service. The service thread does the following. It creates 10 empty service results. Okay, it puts them in a queue so that it's able to pull one from the queue. A queue is not really a list, but it's almost like a list. But a queue is a thing from which, when you need an object, you can pull one. And when you want to put back, you can put back your object. That's how it's meant to work. That's how we use it. Okay. So the service task creates this queue of 10 empty containers of 10 empty service results. And when I want to send back a result, I do the following: I get an empty bin if any. I get an empty service result if any. I put my result inside, and I send it to whoever is listening. Okay. Any questions on this? So I think the main question is this: why do I do this? I mean, it seems completely crazy. I don't know if anybody is wondering this, but I mean, normally when I pass things to another thing, I just call it. I don't create a container that contains, then if I run out. So why do I do this mess? This is a fundamental question. And the fundamental question is answered like this. If I have another activity and I call a method, if I have another class and I call a method, for example, here's another class, I say add, no? It's essentially the same thread. So there is no problem of us having these joint speeds. I call add and I block. Add runs inside that piece of code, but it's the same thread as me. Then, he returns the result. Boom, I resume execution. There is no way in which I can tell him two things to add and he can be late with his additions, right? Because there are not two separate threads. There is one thread when you normally call a method, right? You are in a thread, you call a method of something, you get a reply, you continue acting, that's what happens. So the thing is that essentially somewhere these things are becoming disjoints because the service task is its own thread. And soon we will have to craft messages that go in another thread. Okay, so essentially, I'm packaging. I wish I had a real bean. I have a real banana, by the way. It seems so. It must have materialized from all the message passing examples we did. But so okay, fine. This is a message, and I have a cup exactly like this of this shape that was given to me by Massimo, the author of Web2Py. But so I was really surprised to see it here. But so this is my bin. Okay, I put my message in the bin and I pass it on. And you still can think, look, this is completely crazy because you're passing it on by calling this result callback. Okay, I'm just calling this on result already. I'm not doing any queuing or any. I haven't switched any process yet. Okay. But you will see the problem. The problem is that this bin with a message inside it, the recipient of on result callback will put it into something that will be delivered asynchronously. And so I'm not sure when the cap will be given back to me. That's the fundamental problem. That's why I need to build these containers, okay? Let's look at the other part, and then you come back with questions if you like, okay? Yeah?
Could you explain that last part again? or non-return.
It's as if, I should almost ask us, one of you to stand up as a prop, but I give this to Dustin, who doesn't really stand up, but is here. Dustin takes this cap with a banana inside, okay? And he will put it into a message queue to be delivered to the UI thread, okay? But the cap is freed only when the UI thread frees it. And so I don't know when I will get the cap back from him. So I need to have a small supply of these caps in order to be able to pass them around. Okay, that's the general idea. Sorry. I want to. Okay, so let's look at what happens when I say on result ready. Okay, I'm passing it back to the thread, this bin that contains the result. So it must be here. Yes. What do I do? On result ready is part of the code of the activity, but is running in the thread of the service. So what it needs to do is now craft a message that can be delivered to the activity. And you may think, but this is completely bogus or stupid or an intersection of the two. But the problem is not, because you are not, even though you are in the same syntactic scope, you are really not in the same. You're really not in the same even process scope. These can be two different processes, no? And so we need to essentially package this result in a way that can be delivered to the main activity. And you do this. If the result is not null, I don't know why I have this. I think that at some point I must have been burnt by, no, I know why. It's a complicated reason. It's because at some point I can clear the set of beans. Okay, but it's like a corner case of when you're stopping the service. If you stop the service clears the beans and this result may be null. Okay, but let's not worry about this now, essentially. It's a corner case, okay? So if I get a result that is not null, then what do? I obtain a message. A message has an integer, which is this thing called the display number, because a thread can receive many types of messages. And to distinguish these messages, they have an integer tag so that you can know what these messages are. For example, the thread might receive messages from a service it has started, but also from another service that exists, right? In general, you may receive messages from more than one place. So when I create a message, I need to put an integer tag in it, and I put the result, and I send it to the target. What is this story? What is this MUI handler? Let's look at it a moment. This UI handler is a new handler of the main looper and a UI callback. So this is essentially this. There is this looper that controls everything that you want to be run on the main thread. Okay? And when you want to create a message, you have to create a message and ask it to please be inserted in this stuff that has to be run. Okay? So to do that, you do this. I get a handler for the messages. This handler is essentially the dispatcher of the handler, I guess, a sort of a butler that is there and is in charge of creating the messages and putting them in this queue that is going to be the queue of stuff that is going to be run. Okay, so essentially you create a handler in this way. Okay, once you have the handler, you say, handler, please give me a message, and give me a message that has to have this number and this content. So once you get the message, maybe it would have been easier to write this in 2 lines, but I wrote it in a single one. Once you close this parenthesis, this is a message, right? You have gotten your message, and I send it to target. What does it mean sending a message to the target? This is my handler. When I want to send a message, it does this. I tell you, hey, please give them a new message that has inside 1 and my result. Okay? And when I say send it to the target, it puts it here, right? So it puts it in the queue of stuff to be executed. That means send it to the target and queue it basically. Okay. Once it's enqueued, the looper is in charge of feeding the activity with things to do. There will be not only the things you know about, but also things you don't know about. For example, all the touch events will be somewhere in that queue, right? Because all the touch events will be, calls to functions that will have to execute, in the main activity in the various listeners. So that UI handler in general has a lot of stuff to add. And so when you get to the MUI handler, you are essentially asking, please for a reference to that queue. It's like, I don't know, being on the white list of people that can enter the building, something like that, essentially, when you get that handler. It's the person that can get you into the UI thread, something like that, okay? So once you send the message to the target, the following happens. That, when we created the handler, okay, when we created the handler, we said, oh, by the way, created this handler in such a way that when there is anything in the handler, it gets sent to this UI callback. And when we are in UI callback, we tell it how to handle messages. And if the messages.what is the display number, this matches this. So if the tag is the one we expect, what do we do? Then we get our service result. This is the bin where the result is. If the bin exists, because things can always go funny, then the result has an int value, which is the stupid integer that all the time I've been trying to send from the task to the main activity. Okay, so I can get it and I can put it into a text view. If I still have a service bound to me, because the problem is all kind of stupid things can happen. The service could be sending me back the bin, and by the time I process it, the service might have died, for all I know. I mean, you can never take for granted things that happen in this distributed way, right? So I need to check all the time, if the service still exists and I'm still bound to the service so that I still know what the service is and I still have a good handle to it, then I call release result of result. Release result of result to the service will call release result of the task, which will in turn release result give back the bin that came to me. So if I were to make a drawing a bit more precise than in the slide, I should really update the slide. But what happens is something like this. Let's try to make a drawing that is a little bit more representative. Okay. So I have this integer I. This I gets packaged into a service result. I called it. Yeah, I think so. Service result. Okay. This service result is passed to the activity via simply this on the result method. Did I call it on result? Okay, but this is passed to the activity via on, I think is on result or on result ready, actually. On result ready. Okay. On result ready. This on result ready creates a message, let's call it capital M, that is sent into this queue of messages. Okay. And when the messages get out, this is in the UI handler. No, actually, on UI callback, I think I call it. Sorry, I have it here. Yes, it's called UI callback. When the messages get out, they get out in UI callback. Okay, and here the message. Here I give back R. R is free, and I can use I. So this is a sort of, I need to improve it and do a sliding, which is a little bit better. But this is the general flow. Okay, so You have your integer, you put it into one of the service result fields, and you simply pass the service result field to the people that register to the result. The complicated stuff then happens. When you are in the activity, the problem is that you are in the activity, but you're still in the service thread. So you cannot communicate directly with the UI thread. Okay, so what we need to do is this: you build a message. Messages are this very general mechanism for passing things across random process boundaries. So you build this message that contains your integer, and you pass it, and you pass it to the handler for the messages. When the message is delivered, which is usually immediately, but there might be a small delay if the UI thread is busy doing other stuff. But when the message is delivered, you take the integer and you use it. Now you are in the UI thread. No? Here is in the UI thread. UI thread. This is what happens in the UI thread. All the rest does not happens in the service thread. So if you give your integer, I don't know, you display it, whatever you need to do, and you give back this R to the task. Okay? So this is a complication needed, unfortunately, to pass in a general way stuff from the service back to the original thread. Okay? And this is important, not only for services, but we will see it also for animation. I think after this I should do one lecture on animation, and you will see that these message handlers and these looper handlers have a very general way to do animation. What you do is this: a typical way in which to simple animation is the following. You say, I put in UI thread, I put into this list of things that need to be run, a runnable object that when it's run, it will say, oh, what time is it? Oh, it's 1 second and 27 milliseconds. Last time I ran, it was 852 milliseconds only. So, I'm running, I don't know, I'm doing it by mind, I don't know, but I'm running 180 milliseconds after the last time I ran. Therefore, my asteroids have moved by these amounts, and so I move them on the screen. Oh, and before I'm done, by the way, I put a new instance of myself in the queue of things that need to be run with a certain delay, so that I'm run again in the future. Okay? So essentially, you keep putting in the queue of things to be run a runnable that updates the state of the screen. Okay, so dealing with this queue of things that need to be done in the UI thread will be something that we will have to do in the future as well. Okay, this is one of the two reasons I presented together with services. The other reason I presented together with services is that if you declare the service to run in its own process, you cannot simply send variables back and use mutual semaphores in order to avoid the problems. You really need to, because you are not running in the same process space. You can call a method, but you don't have the same variables defined, essentially, otherwise. And so what you need to do is really craft these messages that then can be delivered to the recipient. Okay, so. So sorry, this is quite complicated, I realize. I don't know if I did a good job to explain it. I tried to do what I could, but do you have any questions on how this works? No, I mean, I don't want to spotlight you, but any question? I'm sure that there are a lot of doubts.
So, what would be like one application of all of this, like a more concrete example, so that we can feel good?
So I'm going to do an example instead of generating random numbers. You might have let me see. Where is this ideas? For example, this background service may be playing music, and it might send messages to the various activities in the UI about which song is now playing. Okay, so you could craft a message that instead of being simply an integer is a song title and a reference to the song database and things like that. This is one possible example. Let's see. Another example might be that I mean, the problem is that you need this complicated mechanism, even if what you want to pass back is very simple. For example, one way, one of the times I built this, I had to build this simply for this reason. I had an activity that for one reason or another was prone to dying. Not only dying, but if the user was a bit fat-fingered and pressed the home button, then you went home and the activity died because the user went away, etc., etc. And for various reasons, I really wanted the activity not to die without an explicit, wish from the user to die to kill it with a confirmation. Okay, so how did I implement this? I had this service running in the background, and essentially the service was checking whether the activity was alive, and if not, it was restarting it. But the service wanted to tell the activity, I'm watching after you every now and then, so that the activity knew that there was a service watching, because also the service can die. And so if the service died, the activity was started. A complicated case, right? But so there was this service that simply passed to the activity every now and then a message that contained the last time it was alive. Okay, and the activity would say, oh great, I saw you alive at this time, so I believe that you might still be running. Okay, essentially a trick so that if you press the home button, the service would be running. It would try to get a reply from the activity. The activity would not reply to one of these I'm still alive messages, and then the service would restart the activity. Okay, I mean, it's a, it's a concrete example I have to do with, essentially. Let me see other examples. Other examples where if you, right, there are a gazillion examples in the books, but what are the examples of that? So, let me, yeah, no.
So you know how you're talking about how you might be doing something else and then it would send a message to change the song title.
Yeah.
Would that be happening while you're doing something, while you're not currently like looking at the screen that is?
Yes, a good question. So this is why there is this on the result. This is why you can bind it to a service, and this is why you can add yourself and remove from the list of listeners to the result. Because if you have music playing and the song changes, but now you are saying in your email app rather than in the music player, you don't want the music player to come back while you're typing a message, right? So what would happen in the music playing app is you create the music player service. Okay, and this service starts streaming the music, and it has some rule so that once one song is over, it chooses the next song, right? And then it would work pretty much as we defined it here. Okay, so the activity, when it's alive, would bind to the service and would register itself to the updates of the service, so that when the song changes, the activity is notified. In the on stop method or on pause method of the activity would say, would essentially delete itself from receiving the updates from the service. But it would not stop the service necessarily, because you don't want the music to stop if you switch to another activity, right? But you want to stop having the display, obviously. So what you would do, I wonder if I do it here, but in on pause, I do this. If I have a service bound, I remove a result callback of this. So this removes this activity from listening to the updates. Okay? Then, in this case, I also stop the service, but this way you don't need to do it. You can leave the service running after the activity has closed. And this is why there can be multiple start service, okay? Because essentially, I started the activity does start service to the service, no? Then binds to it and then registers to the song updates. Then you are there for a while. Then you get out of the activity because now you start, reading your email. The service is still running. Now you say, this music is bad, I want to change playlist. No? You restart the music activity, the music player activity. At that point, it will send another start intent to the service. The service will do another on start method, okay? But it will not create another thread for playing music, because the thread is created in the onCreate method. So the service will not create another thread, no? So essentially that onStart service will not do anything interesting. In fact, we can look at it. In onStart command, we simply start the thread if it's not alive, no? So in case of the thread for some reason died or whatever, we relive it, but we don't create a new independent thread. Yeah, you would create more. Anyway, you would hear like some superposition of multiple musics. Actually, it would be a fun way to discover the bug. Okay, so music playing is one of these activities. Another okay, let me give you another example. Sorry, sometimes it's difficult to think of these examples out of context. But suppose you want to build one of these apps. Actually, I always seem to want to build it, but I never do. That because I have like a physical GPS when I go around. But suppose you want to build your own GPS app because you want to do it in a special way, right? For example, you want also that that same app can transmit to your camera or whatever, no? So, but you want to make sure that if you switch off the phone and put it back in your pocket and you continue walking, that continues, every now and then to get your location. So clearly, you cannot get to the location and record it in an activity, because otherwise, if the activity stops, the service is tossed as well. And so, I mean, the logging is tossed as well. So you need to do this in a background process, okay? But the background process, if the activity is alive, you want to be able to show a map, say, or maybe to show simply some counters. You walked, I don't know, 3 miles and you gained 500 feet of altitude, whatever, no? So if the activity is on, you want to, like here, you want to display the updates to the activity. But if the activity is off, you want the thing to continue logging until you stop it explicitly. And to stop it explicitly, what you have to do is this. You have to reopen the activity. The activity will bind to the service. Okay? And then the activity will have a button that says, stop recording. When you press the stop recording button for the GPS location, just as you can press the stop playing button to the music, then the activity can say to the service, oh, stop service, and that will stop the thread of the service. Actually, that will not stop the thread of the service. That will put the, there is this Boolean flag, right, in the service task. There is this Boolean flag that is called running, right? It will switch it to false. So next time, the thread of the service will check whether it should be running and log in the next GPS position. It will say, no, you should not be running. And then it will release the access to the GPS and switch off in a nice way. That's why you cannot simply, start the thread and say, die now, because the thread that is running to log your location has other stuff going on. The thread might have registered itself as a listener to location updates. Okay, and the location service is something else entirely in Android. If you start the thread to death, then the dialing pointer would remain to the fact that this thing that now no longer exists wanted to be alerted for when there was a new location. I mean, it would be a mess. It's not the proper way. These things have to shut off in an orderly way, essentially, for Android to be happy.
And since you're not doing this, when you need it again, would you just change running to be on again, and it would be the same?
No. Generally, so I mean, I've never done that, but it doesn't work, because once the thread is dead, it's dead. So what you do though is this. Let me check one thing. Let me check one thing in how I implemented it. You see, this is how you restart the thread. If it's not alive, you start it. And when you start the thread, look at what happens. When I start the thread, okay, running is set to true when I start the thread in that way. It's very elementary. But if you set running to true without starting the thread, yes, that variable changed value, but there is nothing that is running now. You need to start with the thread explicitly. And I mean, these are all very good questions, by the way. I wish I got more. So more. What is another good example of service that we can give them? I mean, there is also a difference. So, because often, imagine that now you write an app that enables you to take pictures of people or pictures of stuff in general. And then when you upload these pictures, it tries to do some complicated processing. I don't know, for example, it runs your super duper algorithms to equalize the brightness and transform these into sketches, whatever. And suppose it takes a little bit of time to do these super algorithms, right? Then you have a choice. What do I do with these algorithms? I mean, clearly I cannot randomly rewrite that. So you have a generally two choices. I can create a thread associated with my main activity. Nothing prevents you from doing that. And in fact, I think I should teach you how to do that in one of the next classes. It's a simplified version of this. You create, instead of my task, you call it my job, let's say, okay? And you do, where is it that you actually started the thread? The thread is started here, right? In the onCreate of the service. You create a task, you create a thread and you start the thread. You can run these also from the activity. So now a good doubt that you might have is this. What's the difference between creating a thread from the activity and creating a thread from the service? Okay? I mean, there doesn't seem to be a lot of difference. So is there one or not? We saw what it is. And so the difference is essentially that if you create a thread from the activity, only the activity will ever know of that thread. That means that if the activity is destroyed and you create another activity, that thread, you better have shut it off because nobody can find it anymore. Nobody has a reference to it anymore. And you cannot get a reference to it anymore. So it's a really bad thing to do, to leave threads running that were created by an activity and now nobody has a reference to them. Okay, so for example, if you do this upload of these funny photos and the processing a funny photo takes you 3 seconds, then doing your own thread from the activity is a good solution. Because even if the activity is killed, it's okay if this thread does 2 seconds more of processing, uploads of the image and done. No, it's not really saying too much over late. No. And on the other hand, once it's done, and you don't need to worry. It doesn't really like a prolonged life after the activity is over. Okay? Instead, if you want a GPS logger, you want the GPS logger to be active also when there is no activity, and you want to make sure that when the activity is recreated, it can reconnect to it. That is a fundamental part. Okay, if you created the GPS logger as a service, as simply another thread of the activity, what happens? You touch the home button. No, the activity is taken out of the stack, or maybe it's there in the background somewhere, etc. But then you can swipe and keep, But then, how do you connect to your GPS logger to stop it? No, I mean, it would have to stop. I mean, it cannot continue otherwise, right? So essentially, services are useful where we want things that have an independent lifespan from the activity. If you just need to do background work in an activity that maybe drags even a few seconds over the life of the activity, then you can create the thread directly in the activity, and it's much less pain. Because you don't need to build this system. So another way to look at it, I told you that this binding is like a very complicated concept, and it's true in some sense. But binding solves this problem. How do I reconnect to something? Right? That's why it works with an intent, because the intent are the only way in which you discover stuff in Android. When you don't know that thing exists, you send it an intent to bind, and then the thing may bind back to you, if it does. Okay? But that's how you fish out the things that you created once upon a time, so to say. And Other questions? Any question is good. Yeah.
How does the binding work?
The binding works in this way. So first I start the process, and then I say, please, I want to bind to it. And the bind, you expect it to give you back a descriptor of the process. So the way it works is this. From the main activity, you say, bind my service. So this is simply a function I wrote in order to, I don't know, in case I wanted to bind from more than one place, which actually I don't do. And I create an intent to bind, and I say bind service with this intent. The intent specifies which service I want to bind to. Okay? And when I say that I want to bind, I pass it to the service connection, which is the receptor, which will be called if the binding succeeds or fails. Okay? So in the service connection, sorry, I hate these pop-ups. But in the service connection, what you do is that on service connected, and then here you get the binder. Okay, and from the binder, if you call get service, you get the service. This is a trick, I mean, it's not original from me. I think I copied it from somewhere else. I think actually, I might have copied it. I don't remember from where. I think it's in the official Android documentation. That a simple way to build a binder, if you don't need to do anything more sophisticated, is building a binder that contains a single method that says get service and get the service itself. I think I read it once upon a time in the official Android documentation as a suggestion. Okay, and I found it reasonable, and so I've been using it. Okay.
What complex things can you do? Because you said this is a simple method. What complex things can you do with binder?
Okay, let us assume that the user service is a very different way, which is the other way to use them. Okay, so I give you this, for example, beautiful image processing library that contains a lot of methods. But I don't really want you to know much about the structure of my methods. Okay, and suppose I have, just to give you an example, my super secret methods that are called blur, sharpen, and colorize. Okay, but I don't, for some odd reason, I really don't want you to have the list of all my methods, but I want to have access to those three. Then I build a binder class that instead of having get service that will give you access to all of my methods, whatever, give you a reference of me. I created a binder that does not have those methods. It simply has a method that is called colorize. And if you call colorize to the binder will call colorize to me. It's like a layer of indirection, pure and simple. In this case, I bypass it by having a layer of indirection that I have a method get service that reveals the underlying object. But otherwise, it can be like a layer of, peeling a fruit. No, that sort of hides the content of the fruit, and then if you call colorize on the binder, and the binder will call colorize on me, and then you call I don't know, blur, and the binder calls blur on me. I'm the object that is being hidden, okay? But I may have another method that says, I don't know, find faces, but the binder may not exhibit it to you because they're not getting enough in order to download that binder doesn't give you permission to get that. So I give you a binder that actually does not come with that method because of the way you subscribe to it. Okay, I mean, you can do all sorts of things. Suppose that in the on-bind, in the intent, you have additional data. I'm making it up on the fly, okay, but I'm pretty sure I can do it this way. Suppose that when you bind, you have to give me additional data. And this additional data is a key string. Okay, I can take that key string, use a hash, and see whether the key is valid or not. Valid means that you paid, or that you registered with me in order to use my app. Okay, so if you didn't pay, I let you use colorize, blur, and sharpen. If you paid, I also let you use find objects, find faces, and I don't know, compare images, and a lot of stuff that I consider to be high value. Okay, and so I can put on the Play Store a single library, and I can pass different binders to people that want to bind with me. That's one way. Okay, I don't know if they do it. Okay, I'm purely speculating. But imagine that Google is doing a location service in which internally they want to have for other Google apps more methods available that restrict what the general people see. This would be a way. Again, it's pure speculation. Okay, I mean, I don't know at all if they do that, but they could use it for that if they wanted. But you know, all the services I've used and written actually, and I think 99% of the cases, the service is written as a component of the application, and so you know, this more extra generality of the binder is not really needed. And so having a method get service that gives you the underlying object is just easier. Because otherwise, you know, every time you already, if the task has a method A, you need to add a method that's foo. If the task has a method foo, then you need a method foo in the service. And so there's already this duplication. If you also have a binder, then the method foo would need to be in the task, in the service, and in the binder. You know, 3 times. Any more questions? I mean, I think unfortunately the only thing to do is do a homework on this. Because it's unpleasant, but until you do it, you know, it's hard to grasp. So, I mean, I'll give you all the sample code, so that it won't be all that hard, I hope, right? But I don't see a very good way. If you have other questions, I can answer them to no end. But in the end, you know, you have to take this code and study it a little bit. And so the general points you have to remember is this. The complication of binders is because of that indirect. Because, you know, to me, the main question when I look at this code is sort of, this is nonsense. Like, for such a simple task, do I need to do all this, you know, expletive included, right? And the best I can do is tell you where this sort of, you know, complication comes from. The binder comes from this desire to add a layer of indirection, because you know they thought big when they designed Android, and I think they use it in this way for many things we don't see, including Google Play services. The binder is due to that. This business with the messages is due to the fact that in general the process, the service can run in its own separate process, and so we need to pass things back to the activity, crafting it as a request to please take something and run it in the UI thread, right? So we need to be a bit careful when we pass things back, okay? So that's the reason for all that complication. And the complication about having these empty bins is this, that if you look at the lifespan of the bin, I create it in the service task, okay? I create it and I fill it here. I fill it here in notify result callback. I know I get an empty bin and I fill it. Then I pass it back to the activity. The activity gets it, puts it into a message, and now sends this message to the UI thread. Now, this bin is busy, and the service, you know, the service task will go on doing other stuff. This bin is busy until the UI thread can empty it. So, you know, it's awkward to do with only one bin. If you do it with only one bin, you may lose a lot of messages, right? Just because, you know, the task may be immediately ready with another message, the UI thread hasn't finished using the bin. You know, it's like really in an airport security check. No, you need a certain number of bins in order to so that the asynchronous income of passengers. You know, in this case, you know, if a passenger arrives and there is no bin, you tell them, you know, sorry, fly tomorrow, right? Or actually, no, well, it would be very impolite. But you would have open a trapdoor under the floor and they would simply drop down, you know, and that's what you do when you drop messages, not to do with people, very impolite. Yeah. So the complication comes essentially from these, from this generality and the need of communicating information between these multiple processes that might run at independent speeds one from the other. Okay, and so we need to build this infrastructure. The only redeeming feature is that this story of the messages and the randomals that get into this handler, we will see it later because it's also one of the main ways in which you do animation. More questions? I don't want to do anything else today, so there is a few more dozen minutes like, no, 10 minutes, 5 minutes for more questions. Yes?
You were talking before about locks, stopping maybe, I think, to wait for the process.
Yes.
I
I will talk maybe next time about the how to use logs in general, because it's too late now. But notice that the two data structures that I use that can be modified by multiple threads, I trust them to be concurrency safe. So this pool of pins is a queue that is a concurrent queue. And the other thing I use, which is the list of activities that I'm interested in the callback, that's also concurrency safe. The one thing that is not concurrency safe is this running, but this running, as we discussed with the last team, it's a boolean, so it's an atomic type. So it's true that there can be multiple readers and multiple writers, but actually, the value is not going to be corrected. So you see the reader, the last writer that was ever written. So in general, suppose that you have two things. For example, you keep the height and the sex of a person. So the sex is a boolean, the height is a floating point. And so if you share them between multiple threads, you are able to modify that individual one and the other. But if you want them to be either both modified or not, then you would need to use logs. So that you have this person, you want to change it to the other person, you need to switch the height to another height, and the sex to another sex. But if you don't use a log, you could be the height of the previous person, but the sex of the new one, depending on your okay? But in this kind of running, it's not a problem because it's only a single flag, and so there is really no need for semaphores or logs. So yeah.
So in a sense, you use logs so that they're both of the variables are dependent on one another. Like, because each person is going to have a different height and different, male or female. So
yeah,
you don't want.
Well, we can see. I mean, there's actually I wonder, do you have a class that teaches you about concurrency in Java or not? In Java. In C, not in Java. Maybe it wouldn't be a bad idea if I took a lesson to do it entirely separate from Android and editing, because it's a very general topic. It's very useful for Android, and it might be a good thing to know. So I may do that. Okay, yeah, I may prepare it for either for next time or for the time after, for one of the two times. So I would do a lecture on that. Yes. Okay. So just inform you, the way that these concurrent data structures work is essentially that whenever they have a associated with the object, that they have a single lock, and when whoever calls a method, okay, says it's like a well, no, it's not like that. But whoever calls a method that says the lock is busy, runs inside that method, returns, and then the lock is created. Okay. So even if you say add, if you want to say add, when you say add, the lock is clicked, you run inside. If somebody wants to delete, the lock is taken, so they cannot start running the delete. They are all waiting. Okay. The add finishes, the lock flips back, then the person doing the delete can go in, do the delete, get out. It's like a bathroom in which there is a lock on the main door, but inside the main door, there is a sink, the toilet seat, and all the rest. So whatever you need to do, there is a single lock for the object. Okay, so there is not a lock for each method. Okay, that would be a bathroom with the locks on each compartment. Okay, I don't know. Well, you talk about locks, so that's the kind of lock we see now, red and green, I guess. Okay. Yeah. No, we don't need any of that. So I think I have it very briefly in some slides, but I think that Dustin posted exactly the right link. If you look on Piazza, what you do in order to share is you create an intent and you say, I'm doing by memory, so I'm not sure I'm completely right, but I think you do intent.setURI, and you put what you want to share, which is a URL in your case, as that URI. There is a way to do it. I think it's explained there. And then you simply say start intent of intent. It's intents are this way of switching on another activity. So if you say start intent of that intent is a very generic intent that says intent send, no? And so under we bring up this multiple choice that says we want to share with the email, with messaging, with Twitter, with Facebook, with whatever app that registers as an app that is able to share things. From browser and all whatever is in there. So it will be done for you. It's very pleasant. It's actually one of the great things about that. Any app can insert itself in the sharing with says, oh, I can share as well. Yes.
Sorry, I know I was supposed to be asking, but what happens if you want to password field?
Ooh, right. Maybe it was CD. Yeah, my is better. Right. I should know. Should we change this paper to one that does not have a paywall? Maybe that. The Guardian, what is it? The Guardian, yeah, I don't think they have a paywall. The Los Angeles Times does, San Francisco does not. Mercury News now started doing it. San Jose Mercury News. So, well, but the San Jose Mercury News is actually. So, yeah. I mean, yeah. I don't know. I might give you the BBC and the Guardian. Those are taxpayers supported by some other taxpayers. No, the Guardian not actually. The BBC is. SFGate. Okay. Shall we change it to SFGate and the Guardian or something like that? Removing the paywall newspapers. Yeah, I mean, I don't care, it's just an example. I don't particularly, I just wanted to avoid those newspapers that have these very complicated URL schemes because I didn't want to, it to be too complicated to detect whether we should open outside or inside. That was the only point. So I just picked the.
Credit if we get around New York Times paywall.
Sorry?
Can we get extra credit if we get around New York Times paywall?
By having short code in the window.
I mean, I guess you could close the app daily.
You just clear the server. You just go there.
You just, okay, yeah, extra credit. You just, maybe you should stop the recording, but you click, but you clear your cookies, right? I think it's, yeah. So now you know. So now we have found the practical use of your app, which we should not build. No, I said it, okay? I'm recorded and we should not build it. How do I switch off the recording?